I'm here at Future Food Tech with Michroma founder Ricky Cassini.
For us, it's very important to bring novel natural dyes that perform better than the current natural solutions. Our dyes produced by filamentous fungi produce molecules that are more pH and thermal stable than the current ones we can get from plants like beetroot, betalains. So in order to replace artificial dyes, we need to bring a more robust supply chain, and that's what we are doing through precision fermentation, but also novel molecules that perform better than the current natural solutions.
So on the colour spectrum, are you just focusing on reds, or can you produce a wider range of colours?
We can in fact produce a wide diversity of colors. We started with red because it's the most used in the food industry.
Yes.
Red is 40% of the food dyes industry, and where there is more problems, right? Red 3 was prohibited, red 40 is getting phased out. Natural options fade away when you cook them, like beetroot. Some others like carmine, the production is very limited, so it's very hard to scale. That's why we started with red, but we can produce orange, yellow. Those are 90% of the food dyes market, and we also have proof of concepts of other colors like blues and magentas. And we are also producing white to replace
titanium dioxide. Yeah. I mean, obviously the clean label trend isn't new, and people have been trying to phase out synthetic dyes. But has the kind of MAHA movement accelerated interest from the market?
Definitely, the MAHA movement accelerated the interest from the market a lot. I think it helped a lot also to create more awareness. Of course, we have been talking about replacing synthetic dyes for years, and many companies have already done so, but this movement accelerated the intention of the companies to replace synthetic dyes. I think that there are more than 15, 20 companies that already announced in the last year, the top and the biggest ones in the world. So we believe that that's going to continue through the year. Most of them, they want to replace synthetic dyes, they already did, or they are going to do it this year or the following year, which is very exciting, and it's creating a huge push towards naturalness and a lot of demand for natural dyes.
Where do you see kind of fermentation-derived colours fitting into that natural colours space? Because obviously, you can get these things from plants. Is it certain colours where you can just achieve, greater stability or performance, or is there just an availability issue? Where do you fit into the landscape?
I think the biggest challenges are regarding performance, efficacy, because natural dyes have a way lower efficacy than synthetic dyes that have really high coloring power. So that's partly the problem, but also the huge issue will be supply, because we depend on agriculture, we depend on insects, we depend on bees in order to produce tons of product, and the replacement is not going to be 1-to-1. It's going to be 1 to 50, or in some cases 100 times the amount of biomass we need right now from the synthetic sources. So in order to produce that, we will depend on agriculture if it's not for fermentation. That is bringing a new and more scalable option. We have done a lot of top studies that are required for the process that we need to follow, that is called colorant repetition. Gladly, now with phase out happening, HHS FDA announced the phase out last year. They also announced that they are going to accelerate the approval of new dyes. They want to remove some but bring others to market. And in the last year, we got, I think, 7 new approvals, while in the last 15 years we got 10. So it's definitely accelerating, and we hope to bring our colorants to market soon.
You've recently struck a strategic partnership with CJ, which seems like a powerful way to kind of cross the valley of death in a challenging funding environment. What does your deal cover, and why are partnerships like this important for getting tech like yours to a commercial scale?
As a startup, it's very hard to pay for the capex we need in order to produce at large scale. CPG's companies require tons and tons of product, and as we discussed before, this transition is going to be like 20-50 folds the amount of material we are requiring right now. So in order to reach that scale, we need to scale up with huge partners. CJ is one of the largest fermentation companies in the world, and it's an investor in Michroma. We have partnered with them for the commercial scale up of these ingredients. So we will be able to supply to the increase in demand that we have now in the world. in my opinion, there is a huge opportunity to develop high-value ingredients like colors.
Yes.
But there are other possibilities to develop other ingredients like flavors, fragrances that are also very expensive, that they are produced in an artificial way, and that consumers are asking to replace them. There could be opportunities to produce preservatives and many more ingredients. So I believe that the high value ingredients, high margin ingredients are where fermentation is going to be successful first, and then we will continue to lower type of proteins, etc. That eventually will be cost competitive, but I think we are not there yet. Usually startups in the fermentation space fail in the first steps, right?
Yes.
Going from lab to pilot scale, from pilot scale to industrial scale, because of the robustness of the process. Not only on the fermentation side, but also on the DSP. That's why it's very important to develop the processes from scratch, think them as you are going to scale them, right? And you need to reach the right titers in order to make it profitable. So that's why many companies fail, but there are also issues while you are scaling up. Even you can have the right titer at lab scale and the process can be robust. You can think about the DSP, but if you don't have the capital to access the large scale, which is very expensive, that's another bottleneck, right? So partnering with CMOs, the right partners, in order to reduce your cost while you're scaling up is very important, because those experiments are very, very expensive.
Are there any particular technologies that you're monitoring that think you could be a kind of game changer in the biomanufacturing space?
I believe there is a lot of potential for continuous fermentation, especially with technologies like ours, using filamentous fungi. They could go through a continuous process. Also, the product is secreted to the media, so it would be a perfect fit for a continuous process, which could optimize yields, reduce cleaning times. So that's a quite promising technology.
You've worked with trichoderma for years. What are the pros and cons of using filamentous fungi versus hosts like yeast?
Using filamentous fungi is tricky. You have to pay attention at a lot of things: morphology, rheology while growing the fungi in the fermenter. They're also harder to edit, but gladly now we have the tools to control those processes and make them more efficient. We believe that they do have some downside, but also a lot of more upside, because we can produce much higher titer. They have great secretion mechanisms, which can basically increase the production, the yield of the process, and finally reduce our costs.